Good morning, everybody. Welcome to a Wednesday morning on Chem 1211 with your host, me, Dr. White. Hi. Don't forget the lab that I went through yesterday is due next Tuesday, but the lab we did last week, you should have handed in. Now, if you haven't gotten your lab kit yet, and there are a few of you still waiting, I will extend a window for the labs where you need a lab kit. So don't worry, and I won't take off any penalty points. And if you already have it, get the lab in. Think of it as a sort of a gift that I won't take off points if you're late for these labs because of other people not having the kit. All right, couple important things. Remember, this week you're not tasting test number 1. I had to reorganize everything. I worked on it yesterday. I'm almost done. The way it looks like it's going to happen is there are going to be 6 quizzes, 2 tests, and the final. And I'll have this all in my syllabus. Hopefully by Friday sometime I'll have it posted. But I will tell you this, since you've already studied for test number 1, I'm going to be renumbering my test. My test number, new number 1, will be the same as test 2, and my test number 2 will be the same as test number 5. Confused yet? And the other tests will be split up into quizzes. Now, the way we'll do this, but first, time out for a tea drink. Oh, that blueberry tea is so good. But anyways, here's how we'll be doing quizzes. And I'll put this out in an email also. On the day the quiz is going to be given, I'll have it in Blackboard as an assignment where you will download a password protected PDF file. The day of the quiz, it'll be say on a Thursday at about 8 or 9 o'clock, I'll send out an email with the password. And you'll have, and maybe I take it back. I think I'll do it on Wednesdays. And in the future, next week is going to be different because I got to catch up for what I should have done this week. But the day I give the quiz, you'll download it, you'll take it, and then you'll have until the next day to upload the quiz as a single PDF file. Now, a couple of things. If you do not have a printer, just write the answers on a piece of paper. If you don't have a scanner, you can take your answers, either you printed it and wrote down, or you wrote it on a piece of paper. You're writing it on a piece of paper. You do not have to rewrite the questions. Just put your name, that helps, and the number of the question, like question 1, your answer, if you don't have a printer to print out the quiz. And then you'll scan it, or if you don't have a scanner, I think everybody in this class has access to a cell phone. I don't like calling them smartphones because I've never met a dumb phone. But anyways, oh, it's awful humor Wednesday. But I have instructions, just like you're doing in the lab, where you can take your cell phone, take pictures of it, and then either using Microsoft Word or Apple. I keep on forgetting the Apple name of their machines because I'm an MPC person. But anyways, you can make it into a single PDF file. That way I have instructions, or you can download for your phone the free app, Cam Scammer. Don't pay extra money for the paid version. You don't need it. And that will help you. You'll upload it. I'll grade it. I'll send out an email individually to each of you with the points for each question and the following whenever. And I'm still working out the dates. I will go through the quiz in class. I will cut it out of the video, but I like those special effects. I've been practicing that. But anyways, I will cut it out of the video when I go over answers for a quiz and the test too, but you can always come to my office hours and I'll go through any question. And that's how we'll do it. Any questions on that? Well, in that case, let's get to work. Now, yesterday, yeah, it was yesterday, I was talking about cations. And cations are positive ions, and they are formed when an element loses one or more electrons, and a positive charge is formed on that atom, and we call that a cation. Now, I showed you how to figure out what is the charge on certain elements, and let's do one again. I already did this, but what ion is formed from lithium? And you show the ion by the chemical symbol and superscript right, a plus or minus sign. We'll talk about negative ones in a little while, and a number. And how do you do that? Well, you have to go and find out the following. Go to your friendly neighborhood periodic table. Thumbs up, people. Does everybody see the periodic table on your screen right now? Thank you. All right, now, lithium, Li, and you have to know the chemical symbols. Well, you don't have to, but if you don't want to do good on the quizzes or tests, don't learn them. If you do want to do good, you need to learn them. All right, now, lithium has atomic number of 3, which tells you it has 3 protons, 3 electrons. And numerically, what's the closest inert gas? And when I say numerically, I'm talking about based on the atomic number, the number in the upper right-hand corner of this green periodic table. And you have 2 choices, helium at 2 and neon at 10. By the way, anybody ever see a neon sign? It's got neon gas in there. But anyway, which is closer numerically? Helium is 1 away. Neon is 7 away, which is a smaller number, and hopefully I'll pick 1. So how many electrons does helium have? 2. So let's go back, and how do we do this? We have lithium. It has 3 protons and 3 electrons. The ion it will form will still have 3 protons, but the nearest inert gas, I did it wrong, noble gas, has 2 electrons. Now, to figure out the charge, each proton, 3 of them, has a plus charge. Each electron, 2 of them, has a -1 charge. Do the math, 1 plus 1 times 3 is +3. -1 times 2 is -2. Add them together and you get a +1. How do you show the ion? Chemical symbol. And when there's just a +1 or -1, you just show the sign. So that's the ion lithium will form. And we went through a couple yesterday, but I thought I'd just remind you again how to do that. Now, ions that lose electrons form positive ions. Ions that gain electrons are negative ions. So when an element gains one or more electrons, an ion with a negative charge is formed, and that's called an anion. Oh, by the way, if we call positive charge cation and negative charge anion, you look at a battery, the negative side is called the anode, coming from anion, negative, and the positive side of a battery is called the cathode, which is derived from the word cation, which is a positive charge. Bet you didn't know that. See, chemistry is everywhere. All right, so let's take a look at the following. What ion does chlorine form? Well, let's take a look. Same question, what ion is formed from chlorine? And chlorine, well, hold on. Let me do this proper. You should know that chlorine has the chemical symbol Cl. I do not print L's. Well, I do it in cursive and good habits I'm not going to change. Now, what ion does it form? Well, you do the same thing like we did for lithium. We go to the periodic table and we find, let me move us over here, we find chlorine. It's a halogen, second to the last column. And this has how many electrons and protons? 17. Now, what's the nearest noble gas? Well, argon is 1 away, neon is 17, and krypton is what? 19 away, I think. So what's the smallest number? 1, 7, 19. Hopefully I'll pick 1. So chlorine wants to have the same number of electrons, meaning valence electrons too, to make it stable as argon. So it's going to go from 17 to 18 electrons. Oops, didn't want to do that. So we have chlorine from the atomic number 17 has 17 protons and 17 electrons. It wants to go to the same number of electrons as argon, which is 18, but it will still have 17 protons. Do the math. Each proton has a +1 charge. Each electron, there are 18 of them now, have a -1. Well, do the math. 17 times +1 is +17. 18 times -1 is -18. Add these two numbers and we get a -1. How do you show the ion? The chemical symbol. And since it's a 1, whether plus or minus, since a -1, we'll just put a minus there. And that's the ion chlorine forms. Oh, let's do another one. These are fun. So what ion, 2 or 3 points, does nitrogen form? Well, we have to know nitrogen has the chemical symbol N. How many electrons and protons does nitrogen have? It has 7. Now, what's the nearest noble gas? I almost said inert again. Bad, Dr. White. I learned that name for so many decades when they changed it to noble not long ago. I still have to remember to use it. So nitrogen, atomic number 7. The nearest noble gases, we have 3 choices. Neon at 10 is 3 away. Helium at 2 is 5 away. And argon at 18 is 11 away. So which is the closest? 5, 3, or 11. Closest meaning the lowest number. And hopefully you all pick 3. So it wants to have the same number of electrons as neon. Neon, how many electrons? Look at the atomic number 10. So if we go back to our paper, nitrogen chemical symbol has 7 protons, 7 electrons. It wants to go to nitrogen. It will still have 7 protons, but now it will have 10 electrons. Do the math. Each proton is a +1. There's 7 of them. There are 10 electrons, and each electron is a -1. Multiply it. +7 minus 10. Add them together. You get a -3. So what ion is formed? You show it by the chemical symbol, then superscript to the right. You can do it 2 ways. Dr. White likes the old way. Or you could do it the newer way. I like this way better. Both are correct on its test. This is a skill you should have. Hold on. Let's move up here. And it's Subtle Wednesday. Hint, know this. You should know how to calculate what ions are formed from different elements, just like I did today and yesterday. And we'll go through this again when we go through the problem set on this chapter. All right. Now, so we can form positive ions and negative ions. What good is that? Well, that allows you to form, I'm going to back up. I'm going to back up a long way. A long, long way. 2 days later, I might find it. Here we go. That helps form, or is the basis for, the ionic bond. The transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. So, ionic compound formation. I haven't done this for a couple minutes. Everybody see, thumbs up, people, electron transfer on your screen. Thank you. So we have electron transfer, and atoms can donate electrons, 1 or more, or other atoms can accept those. When such a transfer occurs, positive and negative ions attract each other like magnets to form an ionic compound. And that attraction forms an ionic bond. Now, once again, ionic compounds, there are positive and negative ions held together by strong electrical attractions between opposite charges. And we call that an ionic bond. So when you have ions coming together of opposite charges, they attract each other to form chemical bonds. Now, charge balance in an ionic compound. Well, when we have a formula of an ionic compound, and let's talk about one you're all familiar with, at least I hope you are, and that's sodium chloride, table salt. I wonder, are there any cheer salts out there? Oh, that was awful. Remind me never to use that one again. Anyway, sodium chloride. This is an ionic compound. But you didn't know if you were putting in salt, sodium chloride on your, say, French fries, you're putting ionic compound on your French fries. Now, have you ever wondered, how come sodium chloride is only one sodium and one chlorine? Why not have 3 sodium and 8 chlorine? Or maybe 7 sodium and 3 chlorine? How come it's just only one of each? Well, that's what you're going to learn now. Now, when we talked about, I'll go through this in a little while, but the important thing, the sum of ionic charges in a molecule is always 0. Another way of putting it is all molecules have a net 0 charge. Therefore, when you have a molecule, whether it's ionic, and we'll find out later on, covalent is true too, all molecules have a net 0 charge. I better be subtle. See, I can be real subtle. Hint, know this. This is one of the most important things I know in chemistry. All molecules have a net 0 charge. Therefore, the formula of any ionic compound has a 0 or net overall charges. And the subscripts, or the amount of a formula, are used to 0 this overall charge. And therefore, how do you write ionic formulas? You remember that all molecules, let's back up, all molecules have a net 0 charge. Everybody see my whiteboard where I'm writing on it now? Thumbs up, people. Thank you, Alexis. Thank you, Anna. Two days later, I'll be finished, so hang in there. Now, the question is, write the empirical formula. That means the chemical symbols. I was right the first time, and how many there are. And let's do one. We already figured out yesterday that sodium forms a +1 cation. And we did this earlier today, chlorine forms a -1. So what would be the empirical formula? Well, this is a +1. This is a -1. This has to add up to 0 because all molecules have a net 0 charge. And if you find an example where that's not true, let me know. We'll be rich beyond my wildest dreams. And that goes beyond having my own island in the South Pacific, my own Lamborghini and Ferraris, my own jet fighter planes to play with. Beyond that, it doesn't exist. All right, so if this has to have a net 0 charge, if we have 1 sodium and 1 chlorine, it will be 0. So the empirical formula is 1 sodium and 1 chlorine. And that's why sodium chloride, table salt, has 1 sodium and 1 chlorine. Now, remember, sodium to form a +1 cation lost an electron. Where did that electron go? This didn't fly off into the air. Nope, nope, nope. It went over to the chlorine because chlorine has an extra electron. And that's how you form an ionic bond. And as they say, opposites attract. Have you all heard that? Opposites attract? Oh, story time. My best friend, who I've known since 1965. Wow. We've been friends that long. We met in high school, our sophomore year. In fact, I talked with him a while last night on the phone. He lives about 30-minute drive from where I am in Schaumburg. He's in Highland Park. But anyways, he and his wife, they've been married since, I think, 1978. I stood up at his wedding. His brother was best man. I was second best, I guess, second best, one of the people standing up. But anyways, they are total opposites. I mean, you couldn't get any further opposites the way they are. And it's always amazed me all these years how close together they are. Once in a while, when I think about it, I say, wow, is this like an ionic bond? Now you know I'm a chemist. But in molecules, opposites attract. It's called a Coulombic force. And the plus and minus attract each other electrically, and that forms the ionic bond. Ooh, this is fun. Let's try another one. I think I might have mentioned this, but if you ever go out to lunch, breakfast, or dinner with a bunch of chemists like me, well, someone at the table will say at a restaurant, will you please pass the NaCl? Meaning salt, NaCl, never mind. All right, let's do another one. Write the empirical formula for a molecule with the following ions. We have calcium +2 and chloride -1. So how do we do this? Well, each calcium is a +2. Each chlorine, or chloride it's called, is a -1. This has to add up to 0. Oh, it doesn't. listen carefully. Common mistakes students make. They want to change the charge. You can't. You can change how many they are, but you can't change the charge. If you know a way of doing that, let me know. We'll be rich beyond my wildest dreams. Doesn't happen. But I can change how many they are. If this is a +2, I need a -2, so I need 2 of these. And now +2 plus 2 times -2, which would be a -2, will be equal to 0. But now, how do you write the empirical formula? Well, this tells you there's 1 calcium, but now we need 2 chlorines. How do we show that? Like this. And this is called calcium chloride. And it is an ionic compound because these 2 ions, the calcium +2 and the chloride -1, come together to form the molecule CaCl2. Now, one of the things I like to do in my class, because your instructor has worked in the real world in chemical industry for decades. Oh, I shouldn't have said that, but it's true. And I also live in the real world. And I like to point things out. Now, calcium chloride is a compound you've probably seen, where if you go to a big box store, like home improvement store, like Home Depot or Menards or Lowe's or another one I don't know of, I guess Ace Hardware would be another one. They're not as big as the big box stores, but it's a good place to get things too. I don't get kickbacks from any of them. Shucks. But anyways, in the winter, which unfortunately will be coming soon, you know how when it gets real cold, and there's ice on the street or your sidewalk, and you use the little white pellets or spheres, throw it on there, and it melts the ice when it's well below 32 degrees, well below even 10 or 0 degrees Fahrenheit, when it's super cold. Those little white pellets are calcium chloride. Now, I'll teach you later on, there are 2 materials that can melt ice. Sodium chloride, table salt, but you buy it in a rock salt, or calcium chloride. And I'll teach you later, calcium chloride works at a much lower temperature to melt ice than sodium chloride does. I'll teach you that. But for now, you know, and you can impress your friends, neighbors, and loved ones. Do you know calcium chloride, the stuff we use to melt ice, is CaCl2, because it's 1 calcium plus 2 cation and 2 chloride minus cations. And why? Because all molecules have a net 0 charge. Don't do that. I don't think your neighbors or loved ones wants to hear that. But if you want to try it out, at least you know it now. All right. You know something? I need to share. And here's one for you to try. What is the empirical formula of a molecule with sodium cations and fluoride anions? And remember, all molecules have a net 0 charge. Your turn. And when you're done, give me a thumbs up. Thank you, Alexis. Thank you, Anna. All right, let's do this. So how do we do this? Well, we look at sodium has a +1 charge. That's what this means. And fluoride has a -1 charge. Remember, all molecules have a net zero charge. So if I have one sodium and one fluoride anion, does that add up to 0? And the answer is yes. So what would be the empirical formula? This tells you there's one sodium and one fluoride anion. And therefore, let me rewrite this again. This would be the empirical formula. Now, once again, I like to be in the real world and teach you about it. How many of you, and don't raise your hand or do a thumbs up, how many of you brush your teeth in the morning? Hopefully all do, or sometime during the day. And if you look at your toothpaste, you will find near the end of the ingredients label, by the way, all those things on the ingredients labels are chemicals. You don't think of it, but they are chemicals. You'll see sodium fluoride. And what is that? Well, it turns out back about 1932, 1935, about that time frame, there was a town in Texas where everybody had great dental health. I mean, like almost 0 cavities. And that was amazing. So people researched, scientists, what's causing this amazing dental health? And they found out the only difference compared to everybody else in the United States was their water source that they had for that town was high in sodium fluoride. And they deduced, scientists, that maybe sodium fluoride, taking it, putting it on your teeth and everything by using water when you drink water, or just putting it on, gives you better dental health. And ever since then, they've been putting sodium fluoride, one sodium, one fluoride anion. Remember, it's an ionic compound in your toothpaste. And since about the 1950s, I'm not sure exactly when, it's called fluoridating our water source. If you live in the Chicagoland area, your water you're drinking out of your tap has sodium fluoride added into it to help promote good dental health. I guess that's the way of saying it, or prevent cavities and other problems in your mouth. Now, when I was a kid in grammar school, there was this, how should I put this certain group that was a very fringe group and had these wild theories. And they were going around saying, the government is putting sodium fluoride in your water to control your brain. They also thought anybody who wore red was a communist and enemy of the United States. Yeah, but anyways, no, it doesn't control your brain. It helps promote dental health. Now, when you ask Anna about filtered water, you'll have to test it. I don't know how good the filter you're using, what ions it removes from water. Water that we get from the tap, which is what this is, or if you buy bottled water, unless it's steam distilled, will have ions in it. And there are a whole lot of them. And besides sodium fluoride, key one is calcium and magnesium are there. And the number of ions, the level, and usually they're talking about cations when they say this. Have you ever heard of soft water or hard water?
Yeah.
If the ion's total level is above 150 parts per million, that's called hard water. If it's below 50 parts per million, don't quote me on this, it's called soft water. And that plays a role with certain things, especially how well you get your clothes clean and a whole lot of other things. And luckily, if you're in Chicagoland using Lake Michigan water, that's almost soft. You don't have to treat it. Other parts of the country, you have to treat your tap water before you can drink it. Now, the different water filters you can buy take out a lot of those ions. How well it doesn't, I don't know. I don't use those products because right now, the tap water for me in Chicago is healthy. At one company, I did work at times solving certain problems our company was having, what was then called the Metropolitan Sanitary District of Greater Chicago. And I think they now call it the Water Reclamation Board of Greater Chicago. And those people know their stuff about water real good.
Well, what about like bacteria and like parasites that they are in the water, like in the tap water?
Well, I don't know how well those, now there are different types of filters. And
Yeah,
some
but
of
what
those
about if you like
filters,
drink the tap water without filter?
well,
Is
tap water is treated with, I believe, either chlorine or ultraviolet light. I forgot which they use in Chicago. And that kills just about all the bacteria. So if you drink tap water coming like out of my faucet in my kitchen or your kitchen, if it's Lake Michigan water, you don't have to worry about it if it's coming out fresh because it's been treated. And they have great treatment plants. And if you want, go online to Google and you can see that. But let's move on. Oh, I know what I was going to do. Here's one more for you to do. What's the empirical formula for a molecule with the following ions? Don't forget, all molecules have a net zero charge. So have fun. And while you're doing that, I'm going to take a peek at something. And when you're done, give me a thumbs up. All right, everybody's done, so I better get to work. So the question is, what is the empirical formula for a molecule with magnesium +2 cations and bromide -1 anion? Well, this is a +2 charge. This is a -1 charge. How do you know? You look here. And it has to add up to 0. Why? Because all molecules have a net 0 charge. Well, guess what? This has to add up to 0. Oh, no, it doesn't. This is a +2, but this is a -1. This needs to be a -2 to be 0. I cannot change the charge, but I can change how many of them. And if I have 2 of them, 2 times -1 is -2, plus 2 will now be 0. So what does this tell us? Look here, nothing there. That's the number 1 magnesium. How many of these do we need? The bromide anion, 2 of them. How do we show that? Subscript 2. So magnesium bromide, MgBr2, is that formula, and that's how you do it. Now, when you name these ionic compounds, the first, the cation, the metal ion, which is usually with a cation, is named as the element followed by the name of the non-metal ion, which you take the name like bromine, drop the INE and add IDE. I won't put that on test, but I'm supposed to teach you that, so I have. Now, let's talk about polyatomic ions. Remember, polyatomic ions were a group of atoms that acquire an electrical charge, which is shared among the atoms of a group. In other words, you got a group of atoms sharing together a charge. I'll never ask on a test what's a polyatomic ion, but you need to understand the concept. And why is that? Same question. Write the empirical formula for the following ions. All right, thumbs up, people. Everybody see Mg+2 on your screen? Thank you. All right, so how do you do this? Well, the magnesium cation is a +2. Here we have a polyatomic ion. And notice it has a -1 charge. And all molecules have a net 0 charge, and it has to add up to 0. Oh, no, it doesn't. What do we do? Well, if this is a +2, I need this to be a -2. I can't change the charge, but I can put the number 2 in there. So this means we have in this compound 1 magnesium. But how do we show more than 1 polyatomic ion? Use the brackets. Bracket the ion, polyatomic, close bracket, and subscript. How many do we need? 2. So how do we do this? We looked and said, what's the charge on each ion? Here it's a +2, here it's a -1. All molecules have a net 0 charge, so this has to add up to 0, but it doesn't until I take and make 2 of these. Well, how do we show more than 1 polyatomic ion? By putting them in brackets. And to the right, let me finish, subscript, you put the number. Yes?
So we never touch this number 3 next to the NO, right?
That would be 3 oxygens, 1 nitrogen.
Yes, but we don't do anything with that.
Well, you keep it the same.
Okay.
This is this. This is the important part you use to do this problem, okay? If I look at the clock, it's time for a 5-minute break. Let's take a 5-minute break. I can get up and stretch, and I'll see you at, actually I went over 9:56. Come back at 9:56. I'll see you in 5 minutes. let's get going. How do I look? Ooh, great. I like when I'm wearing red. It's my favorite color. All right, have a request from one of your colleagues to go over how exams will work again. Let's go through this again. I'll be putting this out in my syllabus. I still haven't finalized it. I gotta get the time dates right. And I might put in for the quizzes to be determined at a later date, some of them, but I'll give you a week's notice. All right, there are gonna be 6 quizzes and 2 exams and the final exam. All quizzes will be given online. What that means is you'll download from Blackboard a password protected file. I'll send out an email with the password so you can open it up, take the test. You'll have till the next day to upload it. By the way, I've been doing this since the pandemic, more than 2 years now. And I have things in my tests and quizzes too, will have them that I'll know if you're cheating. And unfortunately, I've caught people, and I'll do what's in my syllabus. So please don't cheat, because I'll find out. Trust me, I've done it, but please don't. All right, so there'll be 6 quizzes. Those will be online. There'll be 2 exams, and both of those, you will have to go to the Glen Ellen Testing Center to take it. All quizzes and tests, since you're not going to be face-to-face, I will email you, send you an email with the actual points you got on each test or quiz. What I might do is sometime before the end of the semester for test number 1, there are only 2 tests, I will hand it back. I'll be at COD if you're interested. If enough people are interested, I'll be there on, say, a Saturday morning, and HSC at the adjunct office. And let's see if people are interested, so you can get back your test number 2. The last test I don't give back usually. All right. Let me explain it again, Michael. There'll be 6 quizzes. Those you take at home. You have nothing to be sorry about. All questions are good questions, my class. Remember that. You should never, ever have to say in my class or in my world, you're sorry for asking a question. All right, let me repeat it again. You're welcome. There'll be 6 quizzes. Ooh, did I get it right? Yep, 6. And those you'll take online. I just explained it. There'll be 2 tests. The 2 tests you have to take at the Glen Ellen Testing Center at COD, obviously. And also there'll be a final exam, and that you will also have to take at the COD Glen Ellen Testing Center. So there are 3 things you have to take at COD itself, where you have to show up there. The 2 tests and the final exam. All quizzes you'll take at home. Let me check. You're welcome. All right, everything clear on that? Let's get back to polyatomic ions. All right, so I was showing you right before our break, the question is, write the empirical formula for a molecule with the following ions. And here I had magnesium +2 and the polyatomic ion nitrate -1. And here, this is a +2. The nitrate, notice right up here, is a -1. And as I've said a number of times, because it's important, all molecules have a net 0 charge. I'll say it again, it's so important. All molecules have a net 0 charge, 0. So what that means is, if you have a molecule with +2 magnesium ion, cations, and -1 sodium nitrate anions. How do you get this to add up to 0? You need 2 of the nitrate anions with 1 magnesium. How do you show that? When you have more than 1 polyatomic ion, you show it this way, bracket NO3, close bracket, subscript 2. All right, let's do another one, and then I'll let you have some fun too. And that would be, I don't know, what letter am I at? Oh, I'm getting alphabetically challenged now. That was awful. All right, I'll do this one, but I will let you try some on your own. The question again is write the empirical formula for the molecule with sodium plus cations. This is called sulfate anions -2. Well, how do you do that? Well, you remember all molecules have a net 0 charge. Sodium cation is a +1. Sulfate, SO4, is a -2. This has to add up to 0. And I write my 0 for this problem this way, so you know it's not the letter O or an oxygen atom. It's not, it's the number 0. And does this add up to 0? Oh, no, it doesn't. This is a -2 plus 1. You cannot change charges, but you can change how many there are. And if I say, well, if this is a -2, this has to be a +2, I'll do this. And how do I write this? This tells me there are 2 sodium and 1 sulfate, SO4. Since there's only 1, I do not have to put it in the bracket. And that's called sodium sulfate. Now, back to the real world. Na2SO4, you've probably seen it in use. It is a molecule that will absorb moisture, water, really good. And have you ever seen those little packets and things that says, do not eat? Give me a thumbs up if you've ever seen those. Like if you buy a cell phone, you might see it in there. If you buy a thumb drive, and I don't have one handy, it'll be in there. Or if you buy certain types of nori, dried seaweed, they'll put that in there, keep it dry. And that's sodium sulfate. And you shouldn't eat it, at least that's what they say. Now, interesting thing, a number of years ago at the other school, I was teaching general chemistry like this. One of the students said, oh, when I was 4 or 5, I ate a couple of those. I jokingly said, well, did it kill you? And she said, no, and we started laughing. But don't eat it, I don't think it's that good for you. So now it's your turn to have some fun with polyatomic ions. What is the empirical formula for a molecule made up of sodium cations? This is called bicarbonate. Anions. Your turn. Oh, you're done. Give me a thumbs up. If you finish early, please be patient. I try and give everybody time to finish. Finish. Thank you, Anna. All right, let's try this. Well, I'll give another 10 seconds for everybody to finish up, including you people who are watching the video. I've never done that before. Probably won't do it again. All right, let's do this. All molecules have a net zero charge. Well, we've got the sodium cation +1. Ooh, we've got the bicarbonate anion, and that's a -1. And all molecules have a net zero charge. Does this add up to 0? It does. So that tells me I have 1 sodium and 1, because the number in front of the bracket here, -1, is 1 bicarbonate. And how do we show that? And let me write it a little bigger. And this is called sodium. Metal name first, and then this is the bicarbonate anion. And this is, so hold on one sec. This is sodium bicarbonate. Yes, Anna?
Do we need to write the name for the each
No,
example?
no,
No.
but I'm
Okay.
teaching you how names are going. I won't have it on test, but it's in the syllabus that you should be at least learning about this. And you are by me teaching you. Now, I'll have to say, most of you probably have sodium bicarbonate in your house. And you'd probably say, no, I don't. And I'd say, yes, you do. What do you mean? Well, let's find out.
Is it sparkling water?
No, hold on.
No.
And if you see on the screen, baking powder, not soda, baking powder. I can't find my brand, Calmet. I wonder why they didn't have a picture here. It's like Rumford, which I've never heard of. Hold on, now there we go. Most of you probably have this in your house. The red can or the other one, Gabler Girl, or if you get it just from a name brand from a big box store. And baking powder is essentially sodium bicarbonate. So next time you use baking powder, in the little can, like the red can or other size can, you're using an ionic compound. Ooh, this is fun. Let's do another one. I forgot what letter I am. I'm on H. All right, your turn. What would be the empirical formula of the molecule formed from calcium +2 and nitrate -1 ions? Your turn. when you're done, don't forget, give me a thumbs up. And you people watching the video, you can give me a thumbs up too. I won't see it, but you can do it. Thank you, Anna. Thank you, Alexis. And please be patient. I'll give everybody time to finish. All right, let's do this. How do you do this? All molecules have a net zero charge. Well, the calcium cation has a +2. We see that there. The nitrate anion has a -1. All molecules have a net zero charge, so that has to add up to 0. It doesn't. Well, I can't change the charge, but I can change how many they are. If this is a +2, I need a -2, so I'll put a 2 there, and that now adds up to 0. How do I show the empirical formula? Look in front here. No number means 1 calcium, and 2 nitrate, NO3. When there's more than 1, we put it in a bracket, close bracket, then subscript. How many do we need? 2. So this is calcium nitrate, CaNO3, and you've got 2 of them here. Now, one quick thing. No, I don't want that. That should be a 2. In our daily life, I think I mentioned the other day, this is sodium nitrite, this is sodium nitrite, and these are preservatives put into meat. That also gives it the pink color. Why it does that, I don't know. That's an area I'm not familiar with, that kind of chemistry with food. But how many of you have ever heard of pink salt?
Yes, it's very popular.
And that's the salt, the sodium chloride, and they put in sodium nitrate, and they make it pink so you know it's not regular table salt to put on your French fries. You don't want to put that with the nitrate, and that helps preserve meat. How? I have no idea how it kills certain bacteria and stuff. That's not my area of expertise, but I do know it because I have used it. I don't know if I told you this or not, but if you're a good organic chemist, you're a good cook. If somebody tells you they're a good organic chemist but a bad cook, they're lying to you, because every good organic chemist I've ever met, including myself, are good cooks. Anyways, back to the chapter. All right, so we talked about polyatomic ions, and now it's time to move on. There's 2 types of bonds, and let me remind you, we're talking about chemical bonds, the forces that hold atoms together. And the 2 types, are ionic and covalent. Remember, ionic is formed by the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms, just like we just discussed. Now, covalent is formed, covalent chemical bond, by sharing of pairs, remember pairs, two electrons between two atoms. So in ionic, you're transferring one or more electrons, but between atoms or groups of atoms, but covalent, you're sharing, and that's an important thing, sharing pairs of electrons. Now, when we talk about the covalent bond or covalent bond model, you can make some generalizations. A lot of the times they're between similar or identical atoms. They involve electron sharing. Now, in your book, they call it the basic unit as a molecule. I call both molecules technically ionic. I'm a little wrong, but unless you're going to be a chemist, don't worry about it. Now, once again, a chemical covalent bond is a chemical bond resulting from two nuclei attracting the same shared electrons. Or a better way of putting it, this is from your book, this is from Dr. White, a chemical bond between two atoms resulting from the sharing of pairs of electrons. So what does this mean? Well, let's look at a very simple molecule that's covalent, and that's hydrogen. I really should have up here gas. And this molecule has two hydrogens. Hydrogen gas has the formula H2. Now, it exists as, like I say, H2. And the structure is this. And what am I showing? This is the Lewis structure for molecules. And the two dots between them is the shared pair of electrons. And these are always valence electrons. The only electrons involved in a covalent bond, which is why Dr. White loves valence electrons, are the valence electrons are the only type. Now, when we talk about molecules and Lewis structures, there are two types of electrons. We have bonded electrons. Those are a pair of valence electrons that are shared between atoms in a covalent bond. This is thirsty work. Again, we have bonded electrons. Those are pairs of valence electrons that are shared between atoms in a covalent bond. And if we go back to here, each hydrogen has one electron. And the Lewis structure for hydrogen with one valence electron is this. Then another hydrogen has a valence electron. And this hydrogen says to this one, I've got an electron, you've got an electron, let's share. And they do. And it looks like this. And these two electrons, a pair of electrons, are called bonded electrons. So the electrons being shared between atoms are called bonded electrons. Now, electrons that are not being shared, pairs of them are called non-bonding electrons. Non meaning not. So non-bonding electrons are pairs of valence electrons that are not involved in the sharing, electron sharing, meaning a chemical bond. I will never ask on a test, what's a bonded electron? What's a non-bonded? But I might ask you, circle in the following structure the bonding or the non-bonding electrons, so you have to know what they are. I just want to ask the definition. So it's time for Lewis practice. But one thing I don't have here that I should point out all right, where are you hiding? Here. And that's the octet rule. When you form, in this case, shared electrons in such a way between two atoms that each atom will have 8 valence electrons. With the octet rule, when you're forming a compound, a covalent bond, each atom will always have 8 valence electrons. And some of those are shared, some of them are not. All right, it's time for Lewis structures for key molecules. And let's do chlorine gas. So 3 points each. Draw the Lewis structure for, and A is chlorine gas. Cl2 is chlorine gas. By the way, this is very dangerous, nasty stuff. I've worked with it. I was in a lab where somebody wasn't careful, got some on his skin, got a very nasty chemical burn. Luckily, you will never handle chlorine. Now, they also use chlorine sometimes for killing bacteria in water, and especially, I don't know if they still do it now, but in swimming pools. Have you ever seen people in the old days where after they were swimming, their eyes would be red? That's because they put too much chlorine gas into the water to kill the bacteria. But anyways, how do you do this? Well, when you see Lewis structure, that means you're going to deal with valence electrons. And how do you find out the valence electrons for chlorine? You look at your favorite periodic table. And if you look into halogens all the way to the right, second column from the right, Cl, you look at the top. Now we're looking at valence electrons, and chlorine has 7 valence electrons. So how do we proceed? Good question. Thank you. Well, I'm going to write the Lewis structure for chlorine. But since we have 2 of them, I'm going to do 2 of them because I want to show you. You don't have to do it this way, but now, if you notice, this chlorine, look how I'm going Technicolor on you, has 1 lone electron, valence electron. And so does this one. And the chlorine on the left, so instead of chlorine on the right, I've got a single electron, valence electron. You have 1. Let's share. And they do. And how does that look? Well, you have each electron being shared right here. But these non-bonding electrons will still be there. Now, if I were in a classroom right now, let me see if I can do something with this. Nope, I can't. All right, if we're just, I know how I can do this. If I were in a classroom, I'd use my hand. Let's just look at this chlorine. How many electrons, valence electrons, are around it? Count them. 2, 4, 6, 8. Ooh, 8, that's an octet. It's happy. If I look at the other chlorine, how many electrons in the purple circle? 2, 4, 6, 8. So both chlorines have 8 valence electrons, which makes them very stable and very happy. But you know how elements can be happy. Not really, but it sounds good. So let's go through this again. To draw the structure, you need to look at the valence electrons, and then single electrons on each atom come together to form a chemical bond. And this would be the answer right here of what you would do. Now, let me point out something that I could have said, circle the bonded electrons, which are these. And what are the rest of the electrons? Like this pair and all around, those are the non-bonding electrons. So in this molecule, Cl2, chlorine gas, you have bonded electrons and non-bonded electrons. And they're always, we're talking about pairs. And that's why chlorine gas is Cl2, 2 of them come together, and this right here is our covalent bond. It's a sharing of a pair of electrons between 2 atoms. Ooh, this was fun. Let's do another one. Now, this is a very dangerous chemical. It's a poison called hydrogen cyanide. Draw the Lewis structure for that. Well, how do you do that? I'll tell you what, let's skip this one. There's a reason why. Let's go back to my list and see what I have else on there. All right, let's do, water. We'll come back to hydrogen cyanide, if not today, on Monday. Draw the Lewis structure for water. You know, the stuff in the bottle, this stuff that you drink, that you never thought of, the water you drink. Oh, that's good water. Is a made up of molecules. This is a chemical. You tend to forget that. Well, how do you draw the Lewis structures, the Lewis structure of water? Well, first of all, we have to find out how many valence electrons hydrogen and oxygen have. And if we go over to our friendly neighborhood periodic table, remember, for Lewis structure, valence electrons. Now, here's hydrogen. We look at the top and see the number 1 valence electron. Here's oxygen, right here. Look at the top of the column, see the number 6. Oxygen has 6 valence electrons. So we now know hydrogen has 1 valence electron and oxygen 6 valence electrons. And the molecule, there are 2 hydrogens. The only way to make this work is with oxygen in the middle. Now, oxygen has 6 valence electrons. They're my 6. Hydrogen, each one, has 1. Now, this hydrogen looks at oxygen and says, I've got a single electron, you've got a single electron, let's share. And they do. The non-bonding electrons, top and bottom, come along for the ride. And then this hydrogen says to the oxygen, I've got a single electron, you do, let's share. And they do. And now we have the Lewis structure for water. And notice in water, there's not 1, but 2 covalent bonds. Right here and right here. Remember, pair of electrons being shared. Now, I must tell you, well, I don't have to, but I will, that the octet rule, there's one exception. And that exception is hydrogen. Hydrogen's octet is 2. Again, octet rule, all atoms want to have 8 valence electrons, either sharing or their own non-shared pairs of electrons. The exception is hydrogen, and the number is 2. Hydrogen's octet is 2. So if I look at this hydrogen, how many valence electrons does it have? 2. It's happy. If we look at this hydrogen, how many valence electrons does it have? And count all the dots in the box, red box, and the answer is 2. So it's happy. So remember, hydrogen's octet, the one exception is 2. Now, if we look at the oxygen, in the blue box, how many valence electrons? 2, 4, 6, 8. And now oxygen has an octet, so it's happy. Didn't know atoms and molecules can be happy. I don't know if they get sad, but they can be happy. Not really, but it sounds good. All right, so once again, how would you draw the Lewis structure for water? And here it is. Make my dots large enough so you can see them. Now, I would ask you, first of all, and I'm going to let you try something on your own, and that is, why don't you circle the bonded electrons in that molecule on your own, or just think about it in your head. And if I were to ask on a quiz or test, draw the Lewis structure for water, I give you the structure, and circle the bonded electrons. Well, what are bonded electrons? Pairs of electrons being shared between 2 atoms. That's a bonded electron, that's a bonded electron. Now, what are the other electrons? This pair and this pair are not involved in the chemical bond, and those are called the non-bonded electrons. And remember, we do things such that all atoms in a molecule, when we're talking about covalent bonds, has an octet. The one exception, remember octet, 8 valence electrons. The one exception is hydrogen. Hydrogen's octet is 2. I can do that in both hands too. Didn't know I was ambidextrous. In real life, I am. And even in real Zoom, I am. Did I tell you I learned how to throw a boomerang with my left hand to come back before I could do it with my right hand? Sometimes that happens to me. Even though I am right hand dominant, I can write with my left hand, even though I don't practice as much. Uh-oh, personal information from Dr. White. And let's do one more. And I'm going to let you try it first on your own. And that's HCl, hydrogen chloride. I don't know what letter we are. I think C, but I might be wrong on that. Draw the Lewis structure for hydrogen chloride. Now I'm going to help you out. Hydrogen has 1 valence electron. Chlorine has 7 valence electrons. And why don't you draw the Lewis structure for that? Your turn. When you're done, give me a thumbs up. And draw the Lewis structure of each one first. Dot on each side before you double up. And thank you, Alexis. I've been working out with my weights big time. Got back to it real big time. I sort of, because of certain things happening in my life, got away from it. And I've been working out. Look at that. Yes, Dr. White pumps iron. All right, since we're almost out of time, I'm going to go ahead and do this, and we'll do more of these. Now, hydrogen has 1 valence electron. You get that from the periodic table. That's the Lewis structure. Chlorine has 7 of them, 1 on each side before you double up. And the hydrogen says to the chlorine, oh, look, I have 1 lone valence electron, you do, let's share. So they do. And here's the Lewis structure. Now let's check. And here's the way you can tell if you're done this correctly. Each atom should have an octet, 8 valence electrons, its own or shared, except hydrogen, and its octet is 2. And here, you notice inside the red box, hydrogen does have 2 valence electrons. Let me get rid of that dot I just put there not to confuse you. And now let's look at the chlorine. And chlorine has these 2 plus 2, 4, 6. 2 plus 6 is 8. It has an octet. So as you'll learn the name of this compound, hydrogen chloride, also sometimes called hydrogen chloride acid. And I'll teach you later in the semester what is an acid. And this is the Lewis structure you would put down. Now, do you have to put all this down here? No, but I'm showing you the thought process, step by step, how you get to the final answer, which will help you on the quizzes or tests. And with that, when I look at the clock, oh no, we're out of time. Time flies when you're having fun with ionic and covalent molecules and Dr. White. With that, I'm going to remind you, if you need help, stop by my office hour. Don't forget, I'm going to be sending out an email. I didn't tell you this. Later in the week, I'll send you an email about next week. Normally, I won't do it, but because this week I had originally planned to give a test and I had to change all that. Does that look like I'm changing things? I don't know. But anyways, I'll send out, check your email. I'll be sending out information about the quizzes we'll be taking next week. And with that, I'm done. And I won't, thank you, Michael. With that, I'll say, gehen gesund, goodbye. Bye now, gehen gesund. Have a nice rest of the week and weekend. And I'll see you either tonight or on Monday.